let's get into some examples. So, problem 4 says determine whether or not f is conservative. So problem 4 is y squared minus 2xy. Now in the book it says y squared minus 2x times I plus 2xy times j. I just wrote this in vector notation. Okay, so this is P and this is Q, and we want to know, is it conservative? So if it is conservative, I should be able to take the derivative of the first coordinate with respect to y, and it should equal the derivative of the second coordinate with respect to x. So you're kind of, if you think of x and y as being first and second, you're taking, this is a what do they say? A mnemonic. This is a mnemonic. So we're going to take derivative of first with respect to second, and this will have to equal derivative of second equals derivative with respect to first. So what I mean by that, I mean check that derivative of p with respect to y is equal to q with respect to x. So let's just check. Okay, so the derivative of p with respect to y, right? With respect to y, I wrote x, I meant y. This is going to equal 2y, right? And the derivative of q with respect to x, this is going to be 2xy, which is 2y. And hey, look, those are equal, so it is conservative. Let's do a few more examples. How about problem 8? So problem 8, we have 2xy plus y to the minus 2, x squared minus 2xy to the minus 3. Okay. Is this conservative? Well, the derivative of that whole thing, I don't want to write it, but the derivative of that with respect to y is 2x plus negative 2 y to the negative 3. And the derivative of the second guy, I'll write it with 2 dots, or I should just say q, right? This is p and this is p and q. Derivative of this with respect to x, this is going to be 2x minus, that x is going to go away, so it's going to be 2y to the minus 3. These are equal, therefore this is conservative, and I'll see you in the next video.